Hello everybody. In the last lecture, we have seen about this stratified random sampling. So we have to understand first why we should make a strata, because in some cases random sampling is a good method of collecting the sample. But what happened? It is applicable or it is suitable for those population when there is a population is homogeneous. For example, at a certain place there is only male population or only female population. So in this condition we can collect, suppose in a classroom there are 100 male students. Okay, so we have to collect the sample from there. So we have selected 10 male students as a representative of that 100 student population randomly, okay, without any discrimination. And after that we applied that sample conclusion to the whole population about the quality of that class, okay. And after that in such, if in that class 50 male students, 50 female students, in this condition if we select sample means randomly, so it is not good, means in suppose in that in that 10 sample two male students and remaining 8 female students, it is not good. So first we have to make a strata or group. So in a 50 male students we can select randomly 5 male student, and in 50 female students we can select 5 female student as a representative of that particular population. So what we have done here, first we have made a strata, like means here we have made two strata, male and female, and after that from that population we have select our sample. Likewise, when we takes our census, in this census is a very good example of stratified random sampling, because while we doing census, so in that we have to count how many infant there, how many kids there, and how many youngsters there, how many adults, and what we call that age old persons there. So this is the one of the good example of stratified random sampling. Okay, let's see merits of stratified random sampling. Sample selected by this method is true representative of the population. Sample has maximum accuracy. This method offers reliable and meaningful results. So this is one of the convenient method of taking the samples. Then systematic random sampling. This is a simple procedure and utilized when a complete list of population from which a sample is to be drawn is available. It is more often applied to field studies when the population is large, scattered, and heterogeneous on field. In this sampling method, samples are drawn evenly spaced after a random start position A is chosen. This is the most practical way of sampling from a large population. Samples are selected every 10th, 20th, 25th or 50th item. Suppose a researcher wants to take 20 cases from 500 HB values. All the 500 values are arranged in some order and one observation is taken from each of the 25th observation systematically. So let us understand, when the population is too large, so for selecting the sample we have to make a strategy. uh, Here, this is also, note out, this is also a type of random sampling, but in this case we have to collect the sample systematically. We have to decide at which point we have to select or collect the sample, like this. Like here, this method is probably applied to the field studies or field survey. So here, in this case, on the 10th point, 20th point, 25th or 50th, like this, so they have selected their point of collection, and then here all the 500 values are arranged in some order, and one observation is taken from each of the 25th observation systematically. So this is one of the good example to clear your understanding. Suppose a researcher wants to take 20 cases from 500 HB values. So total number of population is 500 and he have to select 20 cases. So he have to select 20 cases randomly from 500 population. Okay. Then all the 500 values are arranged in some order and one observation is taken from each of the 25th observation systematically. So each 25th number he have to take as a sample. So the purpose of the meaning of random sampling fulfilled by this method. The first value among the first 25 observation is selected randomly. Suppose this random start point A is 10 is taken. Suppose he has selected the first observation A from the 10th number of individual. Okay, from the individual whose number is 10, or the HB value taken from that individual is that serial number is 10, then the value of 10th observation is in first sample is the start point. After every 25th observation, the sample will consist of the value so of 10th, 35th, 60th, okay, 85th, etc. In such a sample, all sections of the population are adequately represented. Okay, let us see merits of systematic sampling. It is a simple method because sample is determined easily. Results calculated are satisfactory. It saves time and money. Okay, let's go towards the cluster sampling. In this method, the units of population are natural group of elements. These groups are called clusters. Each clusters include only one type of element. A simple random sample is taken from each cluster. Cluster sample provides best results only when the elements within the clusters are heterogeneous. Okay, let's understand here the elements or number of individuals in a clusters. They should be heterogeneous. A cluster can be regarded as a small scale version of entire population. In case each cluster is true representative of the population. Sampling of a small number of clusters will provide good estimates of population parameters. A cluster may consist of units such as village, wards, blocks, factories, children from schools, hospitals, wards, or schools of fishes. etc. So according to module proposed WHO, this method is often used to calculate vaccination results. So okay, so now from these examples you have clearly understand what is the meaning of the cluster sampling. It is quite similar to the stratified sampling, but in this case what happened in a stratified random sampling, we have to make a strata of a homogeneous population, but here what happened, the population in a cluster is heterogeneous, but we have to make a cluster. For example, we have to compare the population of two villages. Okay, so for that, in village there are for example, in that village, suppose in X village the population is 5,000, in Y village the population may be 4,000. Okay, so here the number of population varies, and the population is also heterogeneous in that cluster. So here we are considering two village. So in that as a two cluster. Okay, we are considering two villages as a two cluster, and in that cluster there are so many variation from infant to age old person. So there is so many variations, so we are not putting our concentration on that population. So now we are considering one village as a cluster and comparing in between that, like this. So for example, for a particular type of suppose a PhD student wants to do survey about the child education the quality of child education in villages. So that particular, he or she could not study all villages in India. Okay, also he could not study all villages in that state also. So for that what he or she will do, he or she have to select some number of villages as a sample. Okay, for example, he has selected 10 villages as a sample randomly. So that 10 villages are called as cluster. The same thing is about the wards in hospital. Okay, same things means for example, here factories example is here. So some we can randomly select at about 5 factories in 5 different states or 5 different districts as a cluster to examine the effect of air pollution or water pollution, soil pollution caused by that particular factories, like this. Okay, after that multi-stage sampling. This is also a type of a random sample, but here in multi-stage sampling, the cluster as segment are selected in the primary cluster sample, and these secondary cluster are again sampled instead of being fully inspected. This is also described as random sampling within segment. This method is carried out in several stages using random sampling technique. This employed in large scale survey carried out country-wise and region-wise.